On top right, triangles. And this is one of those times when it's very, very, very good to have notes. Because you'll get them wrong because you think you know the right answer and generally you don't. That's some of you. Looking at triangles, we are classifying them. And we can do it in two different ways, boys and girls. Two different ways. Let's do the first one here. Make it a little bit bigger. How big is that? Okay. The first way, you can classify triangles by their sides. Which means by the length of their sides. For example, one case would be if you have a triangle where no sides are equal. Somebody that is, Jaden, shoot. Rhymes with Kayleen.
Scale.
Yes, good work. Is that a good clue? Scalene triangles have 0 equal sides. You could have a triangle that has 2 equal sides. And by the way, ladies and gentlemen, because a lot of stuff you'll be doing is sketching and freehand, it's pretty tough to draw things exactly right freehand. So in math, when you see lines that have, like these two both have little hash marks through them, that means you're trying to tell somebody that those two lines are equal. It's a sketchy way to do it because obviously you're probably not. Some of you might take out a ruler and do it, but 2 equal sides is a triangle that is called 2 equal sides, right? Harrington is
Isosceles.
Isosceles. Did I spell that right? Isosceles. And then the last one is a triangle that has all 3 equal sides, or our regular triangle from yesterday. Anybody? Brianna? Equilateral. All equal sides. Now, children, Chief, will you close the door? Now, children, there are a couple things about triangles and these different types of triangles that you need to know and make some notes of. First of all would be this. All triangles, the angles in triangles always have to add up to how many degrees? Okay? Yeah, triangles add, all angles of a triangle add up to 180 degrees. So if you know 2 of the angles, you can always figure out the third one because you just figure out what that is there. When you have an isosceles triangle, a couple things are true. Not only are the 2 sides equal, but also the angles that are opposite of those sides are also equal. Angles opposite to equal sides are equal as well. Okay? Which means this. If I know that this angle is 52 degrees, I know that this angle here is 52 degrees. And I can figure out this third angle because I know they all add up to 180 degrees. This is 104 degrees. What do you add to 104 to get 180? You mental math people. 180 minus 104. Elijah? 76 degrees. That doesn't hardly seem, I don't think I drew that quite to scale, but is that right? Yes. That is correct. And then with equilateral triangles, guess what? Equilateral triangles always have 3 equal angles in them, kind of for the same reason that is. And anybody, any idea what every angle in an equilateral triangle has to be? It has to be, no matter what size you draw it, maybe Marco, it's, exactly, 60 degrees. No matter what, no matter how big the triangle is, you can make a little teeny tiny equilateral triangle, every angle is going to be 60 degrees in that. You can make the world's largest equilateral triangle, every angle is going to be 60 degrees. Got that? Everybody happy with that? Now, on the other side of the thing here, that was classifying here by sides. The other side over here, we are going to classify by angles. By angles. Your first, and there's only 3 of these too, so it's kind of nice. There's 3 by sides and 3 by angles. The first one is if every angle is less than 90 degrees, what type of triangle is that? It is an acute triangle. Every angle is less than 90 degrees. If you have one angle that is an obtuse angle, like such, this one here is bigger than 90 degrees. By the way, you can only have one angle bigger than 90 degrees. Could you draw a triangle that has 2 angles bigger than 90 degrees? Negative, why? You should be able to tell me why. Mitch?
Because 90 plus 90 is 180, which is 2 angles.
Yeah, since the triangle only has 180 degrees total in it, if you put 2 angles that were bigger than 90 degrees together, you get more than 180 degrees, which can't happen because that would forget it. What is this one called then? If it has one acute angle in it, one obtuse angle in it, I know this is going to be earth-shattering. It's a, or an, Grace? It's an obtuse triangle. And the last by angles is a triangle that has a 90-degree angle in it. And that one, very simply, is a right triangle. We got right, obtuse, acute, and then on the other side of the board you've got scalene, isosceles, equilateral. And I can tell you, on quizzes to come here, I will ask you to classify a triangle by its sides, and somebody will say it's a right triangle. No, well, unfortunately, that's classifying it by an angle, not by its sides. Is that good? Oh, and then what we have to do, one last thing here, is the area of triangles. What is our formula for the area of the triangles? And I think I will stress the part that most people get wrong. Formula for area of a triangle, Delaney Guiney? The area, I'll put a little triangle down here, of a triangle. Or don't I guess. Anybody? Does not have length in it. And the labels on these are very important, actually. Aaron? What's that? Nope, not length times height. Anybody? Width? Nope, not width times height. Anybody remember what it is? Name our code? Well, that would work, but that's not usually how we say it. Usually we say it is 1/2 of base times height. 1/2 of base times height. It would work the way that Mandy said it. You could take half of the height and multiply it by base, but this is how we write it out. And it's very important that you realize this, children of all ages. The base and the height must form a right angle. It must form a right angle. Here is my triangle. And if this is 10 inches and this is 8 inches, what is the area of that triangle? If that is 10 inches and that is 8 inches, what is the area of that triangle? Do I have any takers on that? Please, somebody help me, work with me. Does it not get any easier than this? People are not volunteering. Any answers, Maddie, Ron? It is not 40. And I think I did this to you last year. I'm really trying to trick you here. Once again, find the area of a triangle. You must have the base and the height must form right angles. What two lines do you see there that form right angles? The answer is none. And you can't find the area of this until the book or the smart teacher in the front of the room does something that looks like this. They will have to. If it's a triangle like this that doesn't have a right angle for one of its corners, you're going to have to be given the height. And you'll know it's the height because they'll draw a little box here that tells you that that is a right angle. You'll have to be given something like this. Now, and only now, can you find the area of that triangle. And what two lines do you use? Only the ones that form the right angles. This 8 does not matter when you're finding the area of this triangle. It would if you were finding the perimeter. Did I do something? So when you do this, it will have to look like 1/2. The base is 10, the height is 6, and the beauty of math is because of the commutative property, you can do this in any order you want. You want to take half of 10 and multiply by 6, you want to take half of 6 and multiply by 10, you want to take 10 times 6 and cut that in half. However you like to do this, the answer is still going to come out to be 30 inches squared. You got that? And I only emphasize that because so many people get this wrong all the time. Well, number one, they forget here. They forget about this. Don't forget about the half part. And then they don't multiply the two lines that form the right angle. So one more example maybe for you would be this. Let's do the big one. Bank, 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 bank. Let's say this is 30 and this is 20 and this is 40. The area of that triangle will be, Laney Clark. What's that? The area will be the height. Where is the right angle? Ah, thank you very much. When you're given a triangle like this, they may end up doing something like this. They will bring a line straight down like this. They'll bring a line straight across like this. They'll always put a little corner in it. You'll have to be given this, which maybe is, what's that look like? Maybe 16 or so. And then you'll write down there, area equals 1/2 base times height. Always write the formula down for me, please. Always sketch out the triangle. Area equals, what is the base and the height? You know, base is 30. We don't have to do this is a material what this line is. You just know that that's dimension there. Height is 16. And again, you can do that any way you want. I'd probably take half of 16, get 8, and then multiply 8 times 30 for 240. Let's make these centimeters. You did this last year, correct? Yes.
Mm-hmm.
So everybody's kind of relatively good with that. And then, of course, if the triangle already is a right triangle, you know, if they give you this triangle here and this already has a square corner in it, and you're given 20, 12, and 16. What is the base and the height of that triangle? Or would that be what are? What is the base? What is the height? What are the base and the height? What would you use for the base and the height there? Genitors. What two lines would you use for the base and the height? Or let me rephrase that, what two lines form the right angle?
Two sides.
Give me the numbers here. What's that?
12 and 16.
Correct. Okay, don't, a lot of people think the word base means bottom, that is not, in math, that is not necessarily the case. You know, the base is the two that form the right angle. It's 1/2 base times height, area equals 1/2 12 times 16. Again, you can do that any way you want. Half of 16 is 8, 8 times 12 is 96. Let's make this miles squared. Whatever it is. Did I do that right? Yeah. Everybody's happy? Do you feel